Welcome to all of you on my channel Physics Hub. Today is 25th of November 2018 Sunday, and it's the time for a new set video. As you know that we upload a set video on every Sunday, and it usually consists of 10 solved problems on different topics of physics. We generally upload the question paper a few days before the day we upload the solution on YouTube, so that you can try to solve the question and match your answers on Sunday. One thing, whenever you upload a video, we distribute it to different relatable playlists. So go through the playlist and you will be able to get videos as per your choice. And one more thing, keep a track of our community post also. There we keep on uploading questions, different questions on physics, which will help you to make your base strong. Now it is quite obvious that your preparation is at peak. You all are solving questions, reading different topics. One thing I would like to tell you here, that keep a quality time for revision. Revision is very necessary. Read, practice and revise, and try to give full length test in this last month. Now without wasting any time, let's start today's set video. So this is question set 19, and this set is based on problems on mathematical methods, electromagnetic theory and electronics. So let's start. The first question reads, the smaller angle in degrees between the planes x, y, z, x plus y plus z equals to 1 and 2x minus y plus 2z equals to 0 is. Okay, so we know that the angle between two planes, this and this, is given by this cos theta equals to mod of this divided by this into this. So this is the formula. You can write the formula. This formula is very important. So what you have to do, you have to just replace the values here. So a1 is here 1, a2 is 2, then b1, b2, b3 all are given. So you just compare and replace the values here, and you will get that cos theta equals to 1 by root 3. Therefore theta equals to cos inverse 1 by root 3, which is equals to 54.7356 degree, approximately 54.74 degree, and it is matching with option 3. So option 3 is the correct option. Moving to question number 2, if the vector function f equals to ax cap into 3y minus k1z plus ay cap into k2x minus 2z minus az cap into k3y plus z is irrotational, then the values of the constants k1, k2 and k3 respectively are. So if f is irrotational, then curl of f is 0. Now we have just used the formula to formulate curl. So I cap j cap into k cap, I cap j cap k cap, del del x, del y, del del z, then the x component, y component and z component, and that should be equal to 0. So what we got, this is equal to 0, this is equals to 0 and this is equals to 0. On doing upon that, we get k1 equals to 0, k2 equals to 3 and k3 equals to 2, and it is matching with option 2. So option 2 is the correct option. Moving on, question number 3, the values of the integrals 0 to 1, 0 to 1 x minus y by x plus y cube dy dx and this are. So look, this integration, these two integrations are similar, very similar, only dy dx here and there dx dy. So this is a little bit clumsy integration, so let's do it. So first what we are doing, we are evaluating this part, the bracketed term. So look, we have to integrate with respect to y. So while calculating this integration, x can be taken outside because x is not independent, x is not depending on y, so x can be taken outside. But here we are integrating with respect to y, so we have to keep y inside. So that's why we have kept y inside. Okay, now it is straightforward integration. Here y is variable and x should be treated as some constant. Yes, or not constant means what can I say, the integration will be with respect to y, and x may be some independent variable here, and to carry out this integration, what we have done, we have done this x plus y minus x. So we just separate this integration into two parts. Okay, and after simplifying, I have simplified the calculations so that you get it simple, and you will see that it will come 1 by x plus 1 whole square. So once we calculate this part, then 1 by 1 plus x square dx, then we can easily calculate this integration, that will be 1 by x plus 1 minus with the minus sign here. Okay, so it is producing half means plus 0.5. Now for the second integration, we don't need to calculate this much, we just predict the value from this integration, because it is very similar to this one. So from this integration we got 1 by x plus 1 whole square. So from this integration you will get minus 1 by y plus 1 whole square for this bracketed term, and dy is there. So we just integrate it and we got that minus 0.5. So it is matching with option 3, 0.5 and minus 0.5 respectively. Next, question number 4. In the circuit given below, the thermistor has a resistance 3 kilo ohm at 25 degrees centigrade. Its resistance decreased by 150 ohm per degree centigrade upon heating. The output voltage of the circuit at 30 degrees centigrade is. So this is, as you can see, this is basically an inverting op amp. So thermistor has a resistance 3 kilo ohm at 25 degrees centigrade. To know the output voltage, we need to know the resistance here and the input voltage. Now the thermistor is temperature dependent, resistive. Its resistance is temperature dependent. So at particular temperature its resistance is given, but we have to calculate it some another temperature. So we need to know the resistance at that particular temperature. Now at 25 degrees centigrade the resistance is 3 kilo ohm. Therefore at 30 degrees centigrade the resistance will be 2250 ohm if it decreases at the rate 150 ohm per degree centigrade. Then now the current situation is, we know that RF and RI, and also we know the input voltage. Therefore we can use the formula to calculate the output voltage for an inverting op amp, and we'll get 2.25 volt, and it is matching with option 3. Look, in general you can discard these two options, first option, because this is inverting op amp, means there will be some phase shift. If you give some negative voltage, here you will get some positive voltage, and if you give some positive voltage you will get some negative voltage. So there is some phase shift in this inverting op amp amplifier. So we have to choose between these two options, and we found that option 3 is the correct option. So one way to solve this MCQ type question, that if you don't know the answer, then what you can do, you can discard the option. Okay, first try to discard one option, then 2, then 3, then the remaining one will be the answer. That's the way, one way, not an efficient way, but comes along. Option 5, question number 5. For the circuit and the input sinusoidal waveform shown in the figures below, which is the correct waveform at the output? The time scales in all the plots are the same. So as you can see, this is the sinusoidal waveform, means the input signal is a sinusoidal wave, and here you see two comparators, two op amps. This is negative, this is positive, means this is an inverting op amp, this is also inverting op amp. Now this is a FET, J FET is connected here. Now you have to calculate, you have to recognize the correct waveforms from these 4 waveforms. So first, what we are doing to solve this problem, we are first considering the negative portion of this input signal, negative portion. Okay, so if we give some negative signal here, so what we can expect here, we should expect some positive voltage as output. So let's see. So this is negative portion, so we should get a positive voltage here, but for this option and this option we are not getting positive voltage, but we are getting negative voltage. So easily we can discard these two options. we can say that these two options cannot be the possible options. Okay, now the remaining two options are these. We have to choose the correct option from these two options. So we have to use some other logic to find out. So let's see. So here FET is acting as a switch. First we are considering negative half cycle. For negative half cycle, voltage V0 will be positive, okay, because that is inverting amplifier and it will have some phase shift. So if you give negative voltage here, it will get positive voltage here. Okay, so in this perspective we discarded 1 and 3, they have already shown. For negative half cycle, if it is forward bias, means gate is forward bias. Look, in case of diode we can say PN junction, we can say it is forward bias or reverse bias, but in case of FETs there are three terminals: gate, source, drain. There we say that gate is forward bias or gate is reverse biased. We are not total FET, but we can say when I say FET is forward biased means gate is forward biased. So now 10 kilo ohm, when it is forward bias means we can think that this is short. So 5 kilo ohm and 10 kilo ohm are in parallel now. So we have to calculate the equivalent resistance to calculate the voltage of this point. So if we calculate the equivalent resistance, we will get 3.33 kilo ohm. Therefore output minus RF by RI into VI means 0.33 volt. So at in VI we are putting minus 0.1 volt. So at the negative peak we should get an output voltage of 0.33 volt. So where in which point it is saved. Look, this at this point, look, the image is not plotted clearly, but it will be 0.33 in this level below this 0.50. So it is matching with option 2. So option 2 is the correct option. So in this way we are not solving the total problem, but we can see the correct answer without solving the total problem. And that's a very good thing about NET question. There you don't need to solve the question totally. You just discover the correct option, that's enough for you, and move on. Otherwise you will not be able to finish it in 3 hours. Okay, next question number 6. For the logic circuit given below, the decimal count sequence and the modulus of the circuit corresponding to A, B, C, D are. So for this problem, as you can see the diagram A, B, C, D, this is most significant bit, this is least significant bit, J, K are given 1. So it's in toggle mode. If you get 0, give 0 at the clock, then it will not change the state of this flip-flop, and if you give 1, it will change the state of the flip-flop. So let's look initial count. Suppose we are giving 1. So in ring counter, basically one bit is shifted with the application of clock pulse. So one high peak always remain in case of this ring counter. So first initially we take that the first most significant bit is 1. So we start with 1. So basically ring counter act like shift register. Okay, so basically this data 1 will be shifted in every clock pulse. So 1, B0, C0, D0. So the decimal equivalent is 8. After next clock, so this one will be transferred to this B. So 0, 1, 0, 0. As you can see, if it is 0, then you will get 0 only. Until and unless it becomes 1, it will not be 1, because this is in toggle mode. So 0, 1, 0, 0, 0, 0, 1. Okay. So consider this part only for the time being. Okay. So 0 0 0. Now as it becomes 1, it will make this output 1. So in the next thing it becomes 1. Now 1 0 0 0 1 0 0 0 1. So it is 1 is shifting from first place to second place and third place. Now again it will come to the first place. Okay, so 1 0 0, and as it was in toggle mode, it will become 1. Now again it has become 0. So in the next successive clock, it is not changing the state of D. So this process continues up to this. Okay, now as you can see, again it has become 1. So when it is 1, it will, as it is in toggle mode, it will change the state of D. So in the next cycle it has become 0, and 1 0 0 0 1 0 0 0 1 is done. So it will start with 1 0 0 0. So it is achieving its original state again. So after 3 3 6, after 6 clock pulse, it is getting its original state. So it's a mod 6 counter. Option 2 is the correct option. Power from a source, the time dependent electric field at a point r theta phi is E r theta phi equals to this, where omega is the angular frequency of the source. The total power radiated average over a cycle is. Okay, to solve this problem came in 2018 June. So electric field is given, therefore we can find out the magnetic field B equals to E by C, and as you know that the total power is measured from the Poynting vector. Poynting vector gives total power per unit area. Okay, so if we can calculate the Poynting vector, and if we integrate over the area, we will get the total power radiated. So total power radiated average over a cycle is given by 1 by mu naught E cross B. So E is perpendicular to B, so 1 by mu naught E square by C. So we have just did this. We have squared this electric field, and we have taken average of this Poynting vector here. So we have to find out the average of this term and this term. And as you know that the average of cos square theta is half, so we have directly put the value half. Now this sin square theta by r square term is troubling us, so let's calculate that. So if you calculate it, the dA means area element is r square sin theta d phi, and here also we are getting some theta and r dependent term. So we have to calculate the integration with respect to phi and theta. So in this way we are calculating it. Integration over phi, there is no phi delta term, so integration over d phi 0 to 2 pi is 2 pi. So to have 2 pi, we have replaced 2 pi. Now we have to calculate sin cube theta d theta, the integration of this. So how to calculate the integration I have shown you in detail. You can check it out. It will produce 4/3. Similarly, cos cube theta will produce 0. So only this thing we are requiring here, where you don't require this. Still I have shown you. You can check it out. So it will produce 4/3 pi E naught square omega to the 4 by mu naught C. So it is matching with option 2. Next question, question number 8. A plane electromagnetic wave is traveling along the positive z direction. The maximum electric field along the x direction is 10 volt per meter. The approximate maximum value of the power rate, power unit area, and the magnetic induction B respectively are. So the wave is traveling in this direction, z direction, and electric field E is 10x along the x-axis, and magnetic field must be along y-axis. Okay, so you have to calculate power per unit area. Power per unit area means the Poynting vector. So 1 by mu naught E cross B. So we are getting 0.265 watt per meter square. And B equal to E by C, 3.3 and 1.8 Tesla. So first, if we can calculate this, we can easily discard these two options 1 and 3. Sorry. So it is matching with option 4. Question number 9. A proton moves with a speed of 300 meters per second in a circular orbit in the XY plane in a magnetic field on Tesla around the positive Z direction. When an electric field of 1 volt per meter is applied along the positive Y direction, the center of the circular orbit. So this is a very trivial problem. Very often you have seen this type of problem. So electric field is along Y axis, magnetic field is along Z axis. So if you calculate it, you will see that the velocity with which the center of this spiral path moves is given by E by B. E is here 1 volt per meter and B is 1 Tesla, so 1 by 1 means 1 by 1 meter per second. So the center of this circular trajectory will move with this velocity 1 meter per second along the direction E cross B. So E and B, E cross B, Y cross Z means X. So it will move like this with a velocity of 1 meter per second. So it is matching with option 4. Option 4 is the correct option. Finally, question number 10. Suppose the YZ plane forms a chargeless boundary between two media of permittivity E left and E right, where E left is 2, E right equals to 1 is to 2. If the uniform electric field on the left is E left equals to C into I plus J plus K, means I cap plus J cap plus K cap, where C is a constant, then electric field on the right is. So this is the situation. This plane YZ, this is the boundary between this and this 1 to E left, epsilon right, and epsilon left is to epsilon right equals to 1 is to 2, means the ratio of the dielectrics is 1 is to 2. E left equals to C into 1 I cap plus J cap plus K cap. So to solve this problem, we will utilize the electrostatic boundary condition, and according to that, the tangential component of electric fields remains constant at the interface. So tangential components are continuous, but the perpendicular components are discontinuous. But in this case, there is no charge in the boundary. It is given to be chargeless boundary. So both the perpendicular and plane, both tangential components will be continuous, but this component is also continuous because sigma f is 0. So from the tangential, equating the tangential component, you get the tangential component C into J cap plus K cap. So we have already known two terms of E right. We have to calculate the components of I cap, J cap and K cap. So you already know J cap and K cap from this property. Now D1 perpendicular minus D2 perpendicular is also 0. So D equals to epsilon E. So epsilon left, E left perpendicular equals to epsilon right, E right perpendicular. Therefore E right perpendicular. We know the two components of E right. Now the last component is E right perpendicular. C by 2 I cap. So we got I cap, J cap, K cap. So all the three components are known now. So we can construct the vector E right equals to C by 2 I cap plus C into J plus K cap. So C into I by 2 half I cap plus J cap plus K cap. And it is matching with option 3. So I have tried my best to provide the solutions in great detail. Irrespective of this, if you have any doubts or confusions, you can comment down below. I will try my best to clarify them, and any kind of suggestions are always welcome. So this is all for today, guys. If you find this video helpful, please give it a thumbs up, make the like button below, and if you are a new visitor of this channel, please subscribe the channel and press the bell icon so that you never miss any update. Keep sharing and keep loving in this way. And what I say finally at the end, thanks for watching.